So the last part of this chapter, as we're going to go through, is working with and identifying function notation in linear functions. So function notation, all this is just a different way of going through and writing these things out. And function notation more primarily is used to give an equation that describes a unique output that we can calculate for every input. So we're going to start seeing it written in a form like we have here. We have an f, we have a parenthesis with a variable inside, in this case x, and an ending in parenthesis. So this is the notation referred to as function notation. And this is not written or read as f times x, it's read as f of x, or fx, or f of x, has the input, and in this case, f of x is the, where am I at here? All these notes were written incorrectly. Someone went and changed them, which is wrong. So in this case, we have f of x is this should be the output value for an input value of x. So these should be reversed. And I'll go through and I'll make an adjustment to these on the notes so you guys can take a look at these accordingly. But f of x is our output value, and x is our input value. We can think of this essentially as, I'll put this off to the side here in red, but I'll write this in. You can think of it as, where's space? Put it off to the left side here. F of x is the same as saying y. So x is still remaining the same thing as it is. It's our input value. Again, it's a typo in the notes. I will go back or go through and revise that. F of x is the same as y, which is our output value. So we're going to go in and see how this works. Here are some examples, but I do want to make that abundantly clear. X is the input. F of x is the output value. Because when we are told about a function, it is given in a function notation. It could be written as f of x, it could be written as g of x, it could be written as h of t, etc., etc. Be very, very, very careful in how you interpret and work with the variables and the values. It is absolutely crucial that you correctly identify the input value and the output value. The rule of thumb, looking at these three forms that we have here, these three examples, whatever is inside the parenthesis is the input value. The entire thing, h of t or g of x or f of x, that entire thing is the output value. So in the parentheses is an input value. The entire result is the output value. So a couple other warnings on how people can and do interpret these things, and these are incorrect. F of x is not read as f multiplied by x, nor do we treat this as a variable f times a variable x. I know up to this point in time we have used parentheses to denote when we are working with multiplication, but now we are going to be taking a step back from that, and with function notation it is going to denote what our input value is for a function and find that overall function's output value. And we'll see some examples of that here shortly. So f of x is not read as f multiplying by x or f times x. It is also, if we have the example f of 3, this is not read as f multiplying by 3 or f times 3. It is not read as those. It is read as the function f with an input value of 3 or f of 3. So we'll go through a couple examples here that we have. Clear this out. On how we input these things. I'm not going to go through all of them because we have a few other parts we need to get through, but again, I'll go through at least one or two of these here. So given that f of x is equal to negative 4x plus 3, evaluate each of the following. So here we're given f of negative 2. And again, negative 2 represents an x value. And the x values in this equation are the input values. Again, typo up here. Whatever is in the parentheses is its input value. So writing this out for ourselves, if we were going to solve this thing, oops, there we go. Wherever an x shows up in this problem, I'm substituting in that minus 2. Why is it? There we go. And then I'm solving this, nothing special. I have negative 4 times negative 8, or negative 2. It's going to give me 8 plus 3, which is 11. Ugh. So f of negative 2 is equal to 11. And again, f of negative 2, you could think of that as just being the y value. So y equals 11, if you want to think of it that way at least. If I have f of 0, again, 0 is our input value. Oh my goodness. Zoom drawing thing is nowhere near the other one. Okay. Let's make this 4 be better because it's looking like a 9 right now. There we go. So in our second example for part B, f of 0, 0 is our input value. So wherever an x shows up in our equation, I'm substituting that x with a 0. So f of 0 is equal to negative 4 times 0 plus 3. Well, negative 4 times 0 is just going to be 0. 0 plus 3 is going to be 3. So f of 0 is 3. And we'd follow the same process with part C. We plug in 7, and we find our answer from there. So again, differentiating, keeping track of for ourselves, what is our input value? What is our output value? And the main reason that function notation is really handy in this regard is, again, we're able to tell the way, based on the way it's written, if I have f of a number, f of a different number, g of a number, h of a number, it's a lot easier to tell what our input value is when we have it written in function notation versus up to this point in time, our other notation that we've been using, y equals a bunch of stuff, might take a little bit extra to interpret what's our input value, what is our output value for this problem, or what am I plugging in as the input value for this calculation versus a different calculation. So I think function notation, while I think it might look a little bit more complex, it might take a little bit longer to get used to. I think it adds a great amount of clarity to what we are going through and calculating and solving each time we are working with a function or an equation that's been given to us. In that regard, that's why we're learning and we are going to be working with function notation a lot more than we have previously. So you can expect to see on future tests and future classes function notation to be way more commonly used than what we have been up to this point in time. So clearing, I think this might not let me, yeah, it's gonna keep those there. So we'll clear these out. Now looking at objective 2 that we have here, we're told use the function f of x is equal to 3x minus 4 to complete the following table and graph. So we would go through, again, correctly identify what your input and what your output variables are. So our inputs are x's, and our outputs are f of x. Again, you could also think of f of x as the same thing as saying y. They're interchangeable with one another. So the y-axis or the f of x axis is our vertical one, and those two are interchangeable with one another. Okay. So this one, we've been given a bunch of input values, and again, just like we did up here, we would write out for ourselves f of negative 2. We would substitute that negative 2 in for x in our equation, just like we did with these examples. And we would find each of these 5 points. And then we would choose 2 of them, plot them on the graph, and connect it together. So again, we're just calculating points and then graphing. Graphing is the exact same thing as we have done previously. Okay? And the only difference that we would have with this is now the way that we are writing out our output values. Instead of putting y equals, we would have f of negative 2 equals a number. F of negative 1 equals a number. F of 2 equals a number. F of 1 equals a number, anything like that. So it's just a different notation to how we write these things. There's not anything monumentally different that we are doing at this point. So I'm going to move us over to our next page. We're getting to something a little bit different here. So for example, or number 3 that we have, use the graph shown below to complete the table. So we're given x values, we're given y, or f of x values we have here. And this is the graph that we are going to be referencing. So at this point in time, once again, determine what your input values are, determine what your output values are. So our input variable is x, our output variable is f of x. So we're being asked, and we have not been given any kind of an equation for this thing, but we are told to use the graph below to complete the table. So when x is negative 2, what is my f of x value, or what is my output value with that? So we come down to our graph and we say, all right, I know x is negative 2. So I go over to negative 2. What is the output value, or the f of x value that corresponds with that? So if I go up to my graph, looks like that's at what, 1, 2, 3, 4, 5. So if my x value is negative 2, what is my f of negative 2 value going to be? And that's going to be 5. We just write that in. It's not letting me do that. Where's the draw tool? We just write in 5. If we're looking at our input value of 0, what is f of 0? So my x value is 0. Okay, great. Go on up. So I'm going to 1, 2, 3, 4. What is my output value, or what is my f of 0 value? It's going to be 4. I'll just fill that in on the table. So similarly with x is 2, my x value is 2, so I'm looking for f of 2. So I go over to 2 here. What's the f of 2 value? 1, 2, 3. It's going to be 3. What is f of 4? 2, 3, 4. F of 4 is 2. So I have an output value of 3 here, and then output value of 2 there. So determining what is our input, what is our output, and then we can look at a graph to also find those input and output values. So looking at this, for number 4, we're told use the graph below. The graph below defines a function that has an algebraic form f of x is equal to mx plus b. So again, this is our slope-intercept form, except written with function notation versus just y equals. So use the graph below to determine the requested values. So here's our graph. We're asked, we want to find f of 0. So again, our general thought is, if the input value is 0, what is the output value? So I should have an answer in an ordered pair of 0 something. So if it's written this way, we have an input value of 0. We want to find its output value. I find 0 on my x-axis. I want to find what is the output value. What is the f of 0 value? And it's this point up here. So what's our output? Writing it in as 4. Thinking on it the exact same way with our value below here. What is f of 2? 2 is our input value. Going over 2 spaces on our x-axis. We're going up to find the y value of 3. We have our answer there. So again, if you're noticing, well, okay, that's the exact same thing that we just did with this table. Completely agree with you. But this is 2 separate ways of writing out and asking for the exact same thing. I want to draw that parallel here. So f of 0. 0 is our input. If we have just x is 0 here. Find its value. The same thing. We're going about finding it the exact same way if we have not been given any kind of an equation to work with for ourselves. Okay. So let's jump to our next part that we have here. Clear these out. We'll scroll down. And I think this has more parts to it on the next page, but I could be mistaken here. It doesn't. Okay, so the table below defines a function that has an algebraic form f of x is equal to mx plus b, slope-intercept form. Use this table to determine the requested input and output values. So our first one we're being asked about, f of 2 is equal to what? So if 2, the input value is 2, which is what it's defined as here, what is the corresponding output value? So again, identify x as our inputs, f of x is our output values. So our input is 2, so I find 2 in my input column. What is its corresponding output value? 4. So I write in for our answer for part A. What is the output? What is f of 2? Well, f of 2 is going to equal 4. Again, similarly with our next part here, part B, we're asked what is f of 4? 4 is our input value. It's in the parentheses, so it's an input value. So x is my inputs, finding that on my table. So I have my input value of 4. What is its corresponding output value? 8. And I plug that in for my final answer here. So what is f of 4? F of 4 is equal to 8. It's the corresponding output with it. Okay. So we have our ideas of working with this thing when we have been given an input value. Now we're going to go with the instances where we might not be given an input value. We might be given an output value. We need to correspond the other things from there. So I'm going to make up a couple examples here really quick. We're going to work with it using this exact same table that we have here. So let's say we have a part C. Now, what if we are being asked to find if f of x is equal to 2, whoops, x equals what? So in part C, okay, I'm kind of making up on the spot, but I do want to highlight this. We're being told f of x is equal to 2. What is its x value or corresponding x value? So 2, is 2 an input or an output value? We are told f of x is equal to 2. F of x corresponds with our output values. So in this case, in our first two examples, we are finding inputs and then finding the corresponding output. Now we have been given an output and we need to find its corresponding input. So we could go either way with what we're being asked about with these problems. So again, identify which one we've been given at the start, and then we find the other one. So again, f of x, the same as saying y. So f of x is equal to 2. Our output value is 2, so I'm going to my output column, where f of x is, and I'm finding 2. What is its corresponding input value, or what's its corresponding x value? It's going to be 1. So if f of x is 2, then my x value has to be 1. Similar idea here. We'll work with one more. If f of x is equal to negative 2, what does x have to equal? So again, I have been given an output value. I'm finding my output values. Where is negative 2? It's right here. What is its corresponding input value? It's going to be negative 1. And that's all I would write in. That's all that I can work with. That's how you work with those ones there. Now again, this has been given to us in a table format. This exact same set of questions or whatnot could be given to us in a graph as well. A graph is just a visualization of a table. So be prepared for being given any of these potential types of questions on a test as a table or as a graph. It could also technically be given to us as an equation, but that would mean I would need to give you the m and the b values written in here as well. So again, correctly identify, have I been given an input value or have I been given an output value, and then I need to solve for the other one. So we have to be given one, we can solve for the opposite. Okay. So I'm going to move us over to our, clear these parts out. I'll move us over to our next series of parts with this. And okay, so we're told to use the graph of the function to find each of the following. And I'm looking at this, and we're going to be approximating these things over anything else because these are this is not a particularly nicely drawn in one. So f of -4, again, we are we have been given an input value, so we need to find where that is on my graph. So an input value of -4, so it means I'm going 4 in the negative directions, my x values. So 1, 2, 3, 4. And I want to find what is f of -4. So I've been given an input value, we need to find the output value. So where is it on the graph? Well, it looks like it's at negative, I don't know, 1 1/4, 1 1/3, something like that, right around here. And again, based on this graph, we can only approximate it so effectively. But on the test or on something homework or anything like that, I'll make it a little bit more clear so there's a bit less guessing involved with this problem. But again, the same idea of what have I been given, what am I looking for? F of 0, I have been given an input value, so 0 here. What is its output value? So F of 0. And it looks like maybe about 1/3, maybe 1/2, something like that, right around here. And our last one, F of 2. 2 is the input value, and I need to find the output value. So F of 2, so I'm going over 1, 2. And then my output value looks like it's about 1 1/4, 1 1/3 again. Again, approximates. That's going to be right at that point on the graph. Again, we can only estimate this because we have not been given clearly defined parts on this graph, which makes even assuming that that's a 1 1/4 something a little bit difficult to do. But we can still, again, the same idea of approximate and find where these output values are along a graph, just like we just did. We're approximating for this example, but same idea holds true. And then in here, for example number 8, we're doing basically the exact same thing that we did with, I think it was example 5. Yeah. We have been given an input value, and we need to find its corresponding output value. So f of 1, 1 is my input. I'm finding one of my input spots right here. What is its output value? -8. So f of 1 is equal, right in here, to -8. Then f of 6, again, I'm finding 6 in my input values. It's right down here. I want to find its corresponding output value, which is 2, which is right next to it. So f of 6 is 2. We have our answer there. Now, we do have the ways, and this is kind of a plus and minus of, whoops, clear these out here. Now, I'm not going to be asking you guys to do stuff to this extreme with how large these numbers get, but you are also able to type in your graphing calculator equations and have it graph those. And then you are also able to look at this table of points, if you wanted to, in your graphing calculator. And I believe we went through this earlier in the quarter as well. Now they want you to use the table setup feature to go through and solve each of these values. Depending on the form of calculator that you have, you can go through and find out and set this thing up for yourselves. I will not be asking you guys to basically go through and do this. To go through and set up and organize your tables, to go through these larger numbers, these larger steps of things, depending on the model of calculator you have, there's about 3 or 4 different ways that it could be. It could ask you to go through and do this. I don't think it's exactly the most worthwhile thing for you guys to use your calculator to go through and graph these super large series of numbers, because you could put an extra 0 or a couple zeros and say f of 0, f of 100, 200, 300, 400, 500, 600. Like, cool, we could do that. We could also just calculate it out for ourselves. Calculator is nice to do that, but again, I don't feel like there's much of a reason to go through and get the big, super huge, giant numbers with those as well. So going through and setting up and solving the tables with really large numbers, no, we can just have it calculate those numbers for ourselves or anything like that. So it will not be asking you guys to do problems like this on the test. Again, I think it's a little bit of overkill and a little bit of extra work to go through and do that than necessary. If you would like to see how that's done, I will go through that with you guys during my office hour if you'd like to, or after class we can go through it. But again, I don't think it's as important to go through and use it to find all these big ones, not to mention the fact of, again, depending on the model of graphing calculator that you have, I'm pretty sure every single one of them has a unique way of having to go in and do that. So if you would like to see that, stay after class and I'll go through that with you, or come to my office hour and I'll show you how your specific version or model of a graphing calculator can make that happen, if you'd like to see that as just some extra knowledge to have and extra tools to use on your graphing calculator. But otherwise, this is everything for going through, working with, and setting up and taking a look at our function notation. And again, the big part that I want to emphasize, and I'll see if I can go and actually edit the original document that this got copied over from. The only difference from our notes, f of x is the output value for an input value of x. So these two things should be reversed from one another. And again, I'll go take a look at the source that this came from and see if I can edit that and then re-upload the all of these lecture notes with that correct wording in there. Because again, this should be output value and this should be input value. F of x is the output, x is the input. Or again, you can think of it as whatever is in the parentheses is the input value. Okay? I want to hit that home because this is an error and I do want to try and fix this for you guys best I can. But otherwise, this is everything for function notation, what it looks like, how we could be utilizing it or working with it on the homework or anything like that. And that's everything that we're using for this for today. So I'll end the recording here and take any questions that you guys have.